So today I'm going to give you a taster video and to basically give you a bit of flavor and what you can expect to learn here at Queen's University, Belfast. And so what you can see here is called Canvas, and which is a digital learning environment provided by the university. And normally, and you will see all the lectures and across the program, and they put their learning materials and for the students to easily access those digital learning materials. And so normally you can see in the home page, and I will put like a welcome message, and especially, if it's your first time and to use this digital learning environment, I'm going to walk you through which are the important areas you should look for. For example, most of the module materials will be available and in the modules. So if you click the modules, you can find a lot of information are quite important, especially at the beginning of the semester. For example, the introduction of the module, and also there is a meet the team, and so you can find the contact information for your lectures and the collected learning tutors associated with this module. And also you can find other important information such as the assessment and feedback and readings and resources, etc. Basically, at the beginning of the semester, I would like to welcome and also getting you some information to get you started. For example, setting up the environment you're going to use. And so in terms of setting up the environment and for all the modules and across the program, and you are going to use either R or Python. So no matter which one you're going to use, and Anaconda is always, a very good platform for you to manage your Python or R libraries. There is a link here, and also there is a video created by me, and so basically you can use either the link provided or the video provided and to get started and with your Anaconda environment. So you first download Anaconda and install the Anaconda. So those steps are very straightforward. So after that, and you'll be able to see the Anaconda has been properly installed. And normally you can only see the environment, the base environment, but I do recommend create your own environment. And the good thing about the use of different environments, so you can separate your different projects and by creating different environments. Now we're going to create a new Python environment. We call it data science, and we choose Python, and then we click create, and now you can see the new environment is being created. So this will going to take you a few minutes and to create a new environment. But after the environment created, and we can start to use this new environment. Okay, now it is created, and then when you click this play button, and you can see there are a set of the options, and now there are only two available for you to use. So we can click open terminal, and so you can see there is a new window pop up. And then if we want to use a Jupyter notebook, now we can just type in Jupyter notebook, and then we hit the enter, and it will start to open a Jupyter notebook for us. So this is a home directory, and normally we're going to the folders and where you save your Jupyter notebook. So normally going to have each of the tutorials for each week, and also going to have the lab practicals and for you to work with. So the tutorial is basically the code contents and in the lectures, and also some guidelines and for you to get started. For example, for the first tutorial, and I have some useful instructions for you to use, like setting up the environment and how to download and install Anaconda. This is also available here, and also how to get started with Jupyter Notebook. So this is basically a Jupyter notebook. So it's very straightforward to use. And so those are the executable cells. And for example, you can create a new cell and just by clicking the insert a cell below. And so for example, we can create a hello world example. So we can create a variable called hello world. And then we can print it out by using the print function from Python. And then we can run the cell by clicking run this cell, and then basically you can see the hello world has been printed out. And there is another way we can do is to click here run, and we can run the selected cell, and we also have the other options like run the selected cell and insert below. So if we click this one, and you can see this cell has been executed, and also a new cell has been created. So basically, when you collect the run and you've been provided with a bunch of different options, such as run selected cell and run selected cell, and insert below, and also the run selected cell for all the cells selected. And now we can go back to the Anaconda and install the Drupal notebook. We click the open terminal, and then we just type in Anaconda install Jupyter, and then we hit the enter. And so by installing the Drupal notebook and in the Conda environment, we can actually save our time. And so next time, and if we want to open the Drupal notebook, and so will be very easy to do it. We don't have to open the terminal again and to type in Jupyter notebook and to open it. Now we're going to proceed. And so we type in Y here and then hit enter. It's probably going to take a couple of minutes and to just install the Jupyter notebook. So basically, you can use this terminal to also install other libraries. For example, if you want to install NumPy or Pandas, and you can install it here. Okay, now it is successfully installed, and we can close the window. And when we hit this play button again, then you'll be able to see there is an option enabled, which is called Open with Drupal Notebook. So that actually gives you a very quick way to access the Drupal Notebook. So we can just click this one, and it will bring up the Drupal Notebook for us. Okay, you can see it opens a new page. Okay, now we can go back to our tutorials. And so basically for each of our tutorials, especially for the first one, we are going to focus on the basics, and you can see a lot of very basic Python programmings and work with different types of data, and how you can do the list, and also using the mapping types and like dictionaries and the set types and booleans, and also other operators and if-else statements. So a lot of the basics in the first tutorial and also first lab practicals. Okay, and so now we're going to get back to our teaching materials. So normally for each of the weekend, we're going to have the engage and apply and also the consolidation. So the engage here, it incorporates the lecture slides, and also under each of the lecture slides, and there will be lecture videos. So these lecture videos are recorded in real time and during our lectures, but you can access them after the lecture if you want to revise the lecture, or you want to go back to a specific area you would like to enhance your knowledge. And then you can also find out we have the applied area. So basically, after you learn the knowledges from the lecture, and then you can start to apply your knowledge. And in one of those exercise, and also there is tutorial available for you to use first before the exercise, and just to help you to go through the important parts and for the practicals. And so you know the tutorials and the exercise, and they are both in the Drupal notebook. So you can so after you know how to install the Anaconda and Drupal notebook, and you can get your working environment ready, and so you can start to use those practical materials. So in terms of the consolidation, and normally what I do is to use a quiz at the beginning of the next lecture. So basically, the quiz is developed by using Slido, and so during the lectures, and I will present those, and in the lecture, and students will do this on their either their mobile phones or their other electronic devices, and so they can answer their questions, and they'll be able to get the feedback immediately. And all of this is anonymized, but I can see the aggregated scores. For example, I can see how many students actually get the correct answer. So this is also good for me to understand about the your understanding of the concepts, and also it's good for the student to check their understanding. So in terms of the teaching content, and we normally will have the theoretical part, and we have the application part as well. The lectures we're going to walk you through the theoretical part, and also we're going to use a lot of real data sets, and for the application purpose of specific theoretical knowledge you've learned within this lecture. And also what I intend to do, and for each of the theoretical knowledges, and I'm going to link it to the AI and machine learning concepts, and let the students understand why they should learn this, and how it's going to be related to the machine learning and AI. So basically, for example, this lecture was about the linear algebra, and first I first, I'm going to present the AI and machine learning motivations and why we need to learn about the linear algebra for AI and machine learning motivations. And because you know all the data sets and the files, and they actually, when they loaded into the Jupyter notebook, and those loaded data set is in fact a matrix. So that's a key data structure in the linear algebra. So that's why I'm going to learn the linear algebra. We're going to learn about the scalar, vectors, and matrices and tensor, etc. And also, apart from the structured data set, and we also have the image data set and the text data set, but you know the computers cannot understand the images and text direct. So that's why we need to convert the images and the text into numerical values. So you can see here is an example to show you that a digital gray image represented by a matrix of the numerical numbers. So this is another application area where you have the categorical values in your data set, and you can use a one-hot encoding method, and basically you can create a matrix and which represent this categorical value. And also, we're going to learn about the matrix factorization and in linear algebra. And this is some very important methods, and which is going to be used in solving the linear regression problem, which is a very important problem in machine learning. So after talking about all these motivations, and we're going to jump through the theoretical knowledges. So we're going to talk about the scalars and also going to talk about the vectors. So those are the mathematical representations, and also it is important to know and how you can do the vectors arithmetics and by using Python, and how you can create a vector in Python. So that's why we're going to introduce the new library, which is called NumPy. So in the next slide, and you'll be able to see there are a few of the screenshots and which are captured from the Jupyter notebook, and which shows you how to create a vector in Python. Now we're going to jump into the Jupyter notebook to show you how to do that. And so this is a tutorial for week 2's lecture. And so here is where you're going to learn how to create a vector by using NumPy. So first you need to install the NumPy, and so basically it's what I showed you before, and you need to open a terminal and use the install NumPy and to install the NumPy. So after the NumPy is installed, and you can import the NumPy. So we can do something here because the NumPy is already installed, so we can just import the NumPy as NP. Okay. So after we've done that, then we can start to use NumPy to create a vector. Now we call it a vector. And so the vector is basically created by a list. So actually we are going to create a list first. So we can call it list A. And so the list A, you can incorporate multiple elements. For example, 1, 2, 3, 4, and 5. So after we created the list, now we're going to use a NumPy function. Now we're going to use a NumPy array function and to create a NumPy array. So now we're going to create a vector. Vector underscore A. We use NumPy array function and to put in the list we created. So now we created NumPy array. Now I'm going to check about what the NumPy array looks like. And after I input the NumPy underscore A, and it displays a NumPy array. So basically it's an array and with a list of 5 values. So after you have learned everything and within that particular lecture, and you can basically test your knowledge and consolidate your knowledge by using the lab practicals. So basically when you're doing the lab practicals, and we have the lectures and also demonstrators at the lab, if you have any questions regarding tutorials and regarding the lab practicals, and you can always find the help. So this is an example of a lab practical. So the lab practical is always relevant and to what you have learned in that week. So for example, for each of the lab practicals, and I give the instructions for each of the exercise, and so you will know exactly what you expected to do. So the first exercise is to import the NumPy and check its version. So this is pretty straightforward, and we can just type in the answers. So what I normally So what I normally recommend you to do is to create a new cell, and basically that means you will not override the results. For example, for this exercise 2, I ask you to create a 1D array, and I expect you to create an array with 10 elements from 0 to 9. So if you type your code there, and if your answer is wrong, and you will override the previous correct result. And so that's why I recommend you to always create a new cell and to write your code there, and to keep the correct answer, and because you can always check it back against the correct answer. Now for this one, it's pretty simple. I'm just using the import numpy as np and then check its version. So in terms of check its version is npy dot underscore version and underscore. So it will print out the numpy's version, and probably you're going to have a different version with my one. So for the second question, it asks to create a 1D array. So here actually a lot of ways, and you can get the same answer. For example, we can create a list first. We can call it list A. So basically you have 10 elements. And you can create a vector A, and which using numpy array function, and to create a vector, and type in vector underscore A, and so it will output the numpy array for you. Okay, so now we can compare our answers and with the provided answer. So it does match, and so that means and you get the correct code. And we can do another thing, because there is actually another function, and which is very easy to use, and which is called, this time we create a new vector. We call it vector B, and we use the numpy range function, and we type in 10. The argument 10 here basically represents, and you are going to create 10 elements. And so I'm going to type in vector underscore B, and so it will print out the answer. So you can see the answer exactly the same. And if you want to know more about this particular function, you can use a help and numpy and arrange, and then so it will bring out the detailed explanation of this function. So basically there are 3 arguments there. You have the start and stop, and also you have the step as well. And so we can basically input all of the arguments here. So we're going to have the from 0 and to 10, and the step value is 1. So it also gives you the exact same answer. And another thing you can do is to search about the numpy arrange function, and in Google, and you can also get the help menu. So what I have shown you here are very basics, and in terms of the Python programming and also the theoretical knowledges. After you have accumulated a lot of knowledges and also the Python programming experience, and you can start to work with the real world data. Now I'm going to show you another example. So this example is about the exploratory data analysis. So this is a very important part, especially for the data analysis process, and it involves the statistical summarizing, and also the exploration, and also the validations of the data. So basically that's the important part, before your machine learning modeling. So you have to pre-processing the data, remove the missing values, and manipulating the data, and to make the data scaled and to be ready, fit into the machine learning pipelines. We're going to just use real-world data sets and to walk you through each of those steps in terms of understanding data, data cleaning, summarizing statistics, and data visualization, etc. So this is a data set I'm going to use, and we're going to use a Titanic passenger survival data set. So actually, you're going to work with more than 20 data sets for each of the module. So a lot of those data sets are coming from open data repository. So there are 2 very famous open data repository. One is called UCI data repository. Another is called Kaggle. So for those 2 data repository, and it is very good, and you can find a lot of data sets you are interested. For example, when you learn a particular part of the lecture and you want to apply the knowledges you have learned, and you don't have to always use the data sets I provided. You can also find a data set you are interested from those open data repositories. Now we're going to carry out the exploratory data analysis. So the first thing, and it's also very important, is to download the data and to load the data and view the data. So previously we talked about the NumPy, and which we use to do the vector arithmetics and matrix arithmetics. And now after we started to work with the real world data sets, and normally it will be saved in a CSV file. So that's why we're going to use Python pandas library. So basically, you're going to use a lot of Python libraries, and which some of the libraries help you data cleaning, data visualization, and the manipulation of the data. And so some of the libraries help you to build up the machine learning models. So you are going to learn a lot of them. For example, like the NumPy, pandas already mentioned, and also you're going to learn about the matplotlib, scikit-learn, TensorFlow, PyTorch as well. Now we're going to jump into the Jupyter Notebook and to see how this works. So in order to do the exploratory data analysis, and we all know we need to load the data first. And so the first step is to download the data, and the next step is to import the data. And we mentioned that we're going to use the Python pandas to import the data. So we need to first import the Python pandas library. Import pandas. When we load the data and into something called the data frame, and so we always use df to represent the data frame, but because you can have multiple data frames and within one Jupyter Notebook, so it's better to give a specific name. This data set is called Titanic, so we can call the data frame df underscore Titanic. So now we can use the pandas read CSV methods to load the data. So normally when you save the data and into the same data repository, and so you'll be able to just type in the name of the data. Because now I'm saving it in a data folder, so I need to type out the directory first. So I can basically type the type key, and so it will bring us, all the available CSV files and save in the data directory. And we're going to use the train.csv file, so we can hit the enter. So we need to run the import pandas SPD first, and then so we can see actually there is no error. So basically that means our pandas data frame has been successfully created, but it's always worth to check about if the data has been correctly loaded. So we're going to use df underscore Titanic and to check about the loaded data frame. So this is one way to check it, and but this is not a very good way, especially if you have a really big data set. It possibly taking a longer time, to just load everything. So I do recommend to use a head function to do the check. The head function normally only gives you 6 lines of the observation, and you can specify the number. For example, you want to check the first 10 lines, and then it can bring up the first 10 lines for you. So basically that's the first step, and in the first step, and you should load the data and into the Jupyter Notebook. After that, and you can see this is your data frame, and in terms of its structure, it looks like a matrix, and you have the rows and you have the columns. So each of the row represents an observation, and each of the column represents a feature. And so basically we have different types of features, and we have the independent feature and we have the dependent feature. So for the dependent feature, we also call it target feature. So this is the target we want to make the prediction. So take this data set an example, because we're interested to predict whether the person is going to be survived. So we are going to use the survived column as the target variable. So we're going to use other features to make the predictions about the target variable. So before we actually build our machine learning algorithms, most important thing is to clean our data sets. Otherwise, there will be lots of errors and throughout, and when you build the machine learning pipeline. So always good to check about the missing values. So we can type in df underscore Titanic, and so we can use the isNow function and to check about and which values are non-values. So basically, this returns a result and for all the observations. And so you can see for some of the features, and if there is true here, that means there is a missing value. So all the false indicate there is no missing value. But this information are not very useful to us, and we are interested to know for each of the features how many missing values are there. So that's why we're going to use the sum function to calculating the number of the missing values for each of the features. So this time is much better, and it gives us the counts of the missing value for each of the features. And we notice that for the age, and it's actually a quite big number in terms of missing values, and also for the cabin, it's really a big number. I think that's possibly more than 80%. We can check about the size of our data set. So we can type in df_Titanic and use this shape. Okay, so basically, for our data set, and we have 891 rows and 12 features, and so you can see the number of the missing values for cabin is really a big value. So apart from those, and we can also do a bit more. So in terms of checking missing values, so we can create a visualizations. So this kind of visualization provides us the information, not only the numbers of the missing values, and also the locations of the missing values. And we can remove the missing values and by using different methods. So we're going to talk about those methods and back into the lecture slides. So in terms of handle missing values, there are lots of ways to do. We can remove the missing values. We can also recode the missing values, and using different methods. We can use a mean value, median value. We can also use other values, for example, like the most frequent categories, if it is a categorical variable. And also there are other imputation methods such as LOCF methods, which is you're creating the new values based on the last observation. And then we can handling the missing value. So there are a few of the rules we should consider. So for handling of the missing values, and we do need to consider about different features. So for the cabin feature, and it has a high number of the missing values, so we can just remove this column. And so in terms of the age column, there are some of the missing values, but also the age column, we feel this feature is an important feature in terms of making prediction of the survive. And so that's why we need to keep this feature rather than remove it. So that's why we need to recode the age columns. And also we see there is a correlation between the age and the passenger class. So that's why we're going to recode the age column based on the passenger class. And now for the embarked column, and we only have very few missing values. And so we can just remove those observations which have the missing values in the embarked column. So after our data set has been cleaned, then we need to do another check. Now we can see there is no missing value presented, so we feel comfortable to move to the next steps. So in the next steps, we can start to use the visualization methods and we've talked about. So in terms of visualizations, then we need to use a new library, which called matplotlib. So this visualization is very useful, and we are exploring the relationship between the target value survival and with the feature sex, because we think there is a relationship between the sex and with the survival. So the plots actually here indicates, and for a larger proportion of the female passengers, they survived in the Titanic compared with the male passengers. For example, if you look at the male, and you will see there are more non-survived and with less survived. If you look at the female, and you can see there are more survived compared with non-survived. So this basically aligns with the historical fact that women and children first is a common principle followed by emergency things like shipwrecks, etc. So basically this showcases and how you can apply the knowledge that you've learned in the lectures and to apply on the real world data set. So basically, apart from of the lab exercise, and I also created some like capstone project. So basically, after a few weeks of study, and you are capable to solve a more complicated problem. So this is where the capstone project came up, and you will have the opportunity to apply the knowledges you've learned within the, for example, a few weeks, and then you can work on a more difficult problem, and you can work with a real world data set and with a more difficult problem. So for example, the first few weeks will be about the linear algebras. And so after you learned about the metric decomposition and the dimension reduction, so you'll be able to work on a more complicated data set and to do dimension reduction. And also, for example, for the second project, and where you have learned about the statistics and also visualizations and data exposure analysis, and you can start to work on a few more complicated data sets and to test your knowledges and also to see what insights you can obtain for those projects. So basically, you're going to learn the theoretical parts, and also you have the opportunities to apply the theoretical knowledges you've learned within the module and in more complex real-world problems, and you have the ability to use the programming skills you've learned to solve the practical problems. Thank you very much.